Okay. Hello guys. So in this session, we'll discuss on modularization techniques. What is modularization? Anyone of you familiar with this word? Modularization.
I think manipulations, right?
No, not manipulations. So we modularize the code using modularization techniques. We can modularize the source code. What do you mean by modularizing again? So we are going to divide code into different reusable blocks, different reusable objects. Modules are blocks. So by using modularization techniques, what we can do? We can divide the complete source code into reusable modules or blocks. So by using modularization techniques, we don't need to write complete source code in a single program or in a single object. We can divide that complete source code into different reusable modules. Can you tell me one reusable object what we have created so far? Can anyone of you tell me one
Data
reusable
elements.
object? Yes, data element, right? We are reusing it in different tables, right? We are reusing it in structures, we are reusing it in programs.
Listen.
But modularization technique is not similar to data element, but data element is also for reusability. That is for sure, right? Modularization techniques are also for reusing the existing functionalities without creating again and again the same functionalities in different programs. For that, what is required? We need to modularize the code into different reusable modules so that you can reuse the same functionality in different programs whenever required. You don't need to write from the beginning every time. Okay. So here, instead of writing the complete source code in the main program, what you will do? You will divide that code into modularization blocks and you just call those modules in your program instead of writing source code directly in the program. Okay. So there are different types of modularization techniques. So what is the concept of modularization? What is the concept of modularization? Modularization is used to divide the source code into reusable blocks or reusable modules. Okay, clear? What are the advantages of modularization? We can reuse the functionality. Okay, we can reuse the functionality. You don't need to create again and again. If you have a similar requirement, you don't need to create from the beginning. You can just reuse the functionality. Flexible to update the functionality when we update something, when we update something, when you update a app in your phone,
Changes.
when there are some new features or some changes happened, right? So to add those new features, you need to update your mobile application. Yes,
Yes, son.
right? Here also, so you have already implemented a functionality, but there is some change in the functionality after few days, maybe after few months, right? But that functionality is being used in 20 programs, the same functionality. Okay, the same functionality is being used in 20 programs. For example, that functionality is tax calculation, some tax calculation functionality. Okay, you implemented that tax calculation functionality in 20 programs. Now, after few years, government changed the tax policy. Government changed the tax policy. They did some changes in tax system, right? So accordingly, you have to adjust all your functionality, right? When there is a change.
Yes, sir.
Now, in how many programs you need to change that functionality?
20 programs.
20 programs, right? You need to go to the 20 programs and you need to update the functionality according to the new tax structure, right? When this will happen, when you did not modularize your code, when you did not modularize your code, you have directly written the tax calculation functionality in all 20 programs. You did not modularize it. Then you need to go to every program and need to update the functionality. Let's assume, let's assume you created a module, you created a separate object to maintain the tax functionality, to maintain the tax functionality without directly writing the code. You are just calling that module in the 20 programs. You are not writing any code related to tax functionality in 20 programs, but you have written all your code in one module and you are just calling that module in your program. Now tell me how many objects you need to change to update the tax functionality. If you modularized it using a module or a function, you just need to change that code in only that one function. It will
Yes.
reflect in all the programs. It will reflect automatically in the all the programs, whatever the programs that is calling this module, right? It is easy, right? You don't need to go to change the 20 programs,
Yes, sir.
right? So if you modularize it, you can easily maintain your code. Maintain in the sense, if there are any changes, you don't need to change in everywhere. You just need to go to that module and change there, right? And can reuse the functionality. Whenever you are creating a new program, you don't need to write the tax functionality from the beginning because that is already implemented in the form of module. Just call that module. That's it. You don't need to write anything, right? That is reusability. Reusability and easy maintenance of the code or flexibility to update the functionalities. Okay. Now I'll just show you one example here. Let's assume it's a program. Validate customer. Validate customer. What is the customer master table?
KNA1.
So how can you validate the customer number? By selecting the data from KNA1 table, right? to validate the customer number. Is it a valid customer number or not? For that, you need to
Yes.
write select statement on KNA1, right? You need to write select statement on KNA1 to validate the customer data. And then I have another functionality. This functionality is to read PO data. PO data means purchase order data. Read purchase order data. Maybe I'll take it to sales order data because we are using customer, right? If we are using vendor, purchase order will be suitable. So read sales order data. How many tables you are going to join here? Maybe around 5-6 tables you are going to join. Maybe more tables. Depends on your requirement, right? To read the sales order data. So you implemented these two functionalities in the program. Now I have a requirement to create another program. Here, how many like you may have implemented 5 to 6 joins using different conditions. And for validation, you have implemented the validation functionality to read the data from KNA1 and displaying the error message if it is not a valid customer. Now I have a different program where I need to use same data selection. For example, read sales order data. I have a different program. Here also, I have a functionality to read the sales order data. What I need to do here? I need to create that data selection from the beginning. I need to create the data selection from the beginning. You need to write the select statements and you need to identify the joins and you need to identify the join conditions and everything from the beginning, right? If you don't modularize the code, let's assume we kept this validate customer functionality in one module. For example, let's name it as M1 and read SO data in one different module. Without instead of writing directly in the program, we kept inside a module or a function. M1 is for validate and M2 is for read SO data. Now, do you need to write it from the beginning here in the different program? Do you need to write everything from the beginning?
No.
I will just
Is the
call
module.
M2.
The mod-
You don't need to worry about join conditions. You don't need to worry about different tables relations, right? When your requirement is same in a different program, just call that module. That's it. How much time it will take? Hardly 1 minute to call that module, right? But to develop this original module, it may take 1 week, right? But here in the new program, if you start developing from the beginning, again, it will take 4 or 5 days to complete that functionality. When it is the similar functionality, you can modularize it and you can call it in the different programs. Okay. For validations also you can just call M1. Okay. Depends on your requirement. Let's say I have a different program. I have a different program. Here I need to have I have a same same input parameter, that is customer. For that I need some validation on the customer. Do you need to worry about validation logic on the customer number? No, just call M1. It will take care of the customer validation. Similarly, you can call in any number of programs, right?
Yes.
For example, let's assume there is some changes in the customer master data. There is some changes in the customer master data. For example, they changed the table name. They changed the table name. Do you need to change that relevant functionality in all the programs? If there is any change in
No, sir.
customer validation, do you need to do the changes in all the programs? No. Just go to this module and change the functionality. It will automatically apply to the all programs, whatever calling this module. For example, there is a change in sales order data selection. There is a change in sales order data selection. Do you need to change in all the programs? No. Just go to that module and change there. It will automatically applies to all the programs, whatever calling. Clear? Is everyone
Yes,
clear?
sir.
So we
Yes,
have
sir.
different modularization techniques. So there are some outdated techniques and some important techniques which we are using in recent times. Okay. So I'll provide you the list and then we'll focus mainly on modularization techniques which we are using in the recent time projects. Okay. Not on the outdated things. First technique, subroutines. Subroutines. Subroutine. Subroutine is a modularization technique. You can modularize the code. You can modularize the code and you can call the same functionality in multiple times. But subroutines can be called in the same program. You cannot call subroutines in different programs. You can reuse subroutines within the same program.
Program.
Same program. Within the same program, you can reuse it any number of times. For example, call M1. Again, you need to write the same functionality. Call M1. Like that, repeatedly, you can call the same functionality using subroutines. Okay? Clear?
Sir.
These are local to the program. Okay? Local to the same program. You can reuse only within the same program. Okay? Second one is function modules. In C, we call it as functions. So both subroutines and functions follows procedural oriented programming language. What is procedural oriented programming language? C is the example for procedural programming language. It uses functions. Okay? It uses functions. So function modules are modularization techniques. Can can be called in different programs. So function modules can be used globally. The function module can be called in any program. You can call one function module within the another function module also. You can write, you can call one function inside the other function. You can call the function module in a program. Okay. So this can be used globally. You can call it in any number of programs. Okay. What is the difference between subroutines and function modules? Subroutines can be called only within the same program. These are local to the same program. But what about function modules? Function modules can be called globally. You can call it in the any program. Okay, that is the difference. Classes and methods. So inside the class we have methods. So these class methods follows object oriented programming approach. Which one? So classes and methods, class methods follows which programming approach? Object oriented programming approach. Object oriented programming approach. So there are certain features of object oriented programming than procedural oriented programming. In procedural oriented programming, what do we use? Functions.
Functions.
Functions. In object oriented programming,
Class methods.
classes, and inside the classes we use methods. Okay. So there are certain advantages of object oriented programming than procedural programming, like data security, reusability, right? There are certain advantages. We'll discuss that in detail when we are working on object oriented programming. But class methods also we can use for reusability. Follows it follows object oriented programming, can be called globally, can be called globally. And here we have a concept of local classes and global classes. Local classes and global classes. Local classes are local to the same program, but global class you can call in any program. Okay.
Yes.
C24 is the transaction code to create the global classes. Okay. So there is another modularization technique that is called macros. I think no one using those macros in these days, but again I'll mention. Sorry, I completely forgot one more. Subroutines. Sorry, include programs. Include programs. Include programs. This is another modularization technique. This is another modularization technique. So what is the type of programs we created as of now?
Executable code.
Executable program. Okay. Executable programs we created, right? So we can create other type of program, that is include program, and we can keep some functionality in the include program, and we can call the include programs in other programs. So whatever the functionality you implemented inside the include program will be part of that main program. Okay. Can be called in other executable programs. Cannot execute the we cannot execute the include programs. Okay. It won't accept any input and it won't return any output. Just like executable programs, it won't accept any input and it won't return any output. So what is the purpose of include programs? Reusability, reusing the functionality. We can keep the code in the include program and you can reuse it. So we can modularize the main program by using include programs. Okay. Okay. So how can you call include program in main programs? Using include and program name. So whatever the functionality you implemented inside the include program, right? Those will be automatically added to the main program. So you can call include programs in any number of programs, any number of programs. Okay. Clear?
Yes.
Can we define selection screen in include programs like parameters, select options?
Yes, sir.
No. You can
We
define,
can.
but you cannot execute independently. So you can define, but they are not going to be, they are going to be part of a executable program when you execute the main program, but you cannot uh, directly execute the include program. It won't to display any selection screen even if you place parameters and select options in the include program, and if you execute it, it won't show any selection screen. But when it will display, when you added this include program to executable program. Clear?
So one more time.
So you can keep selection screen parameters in the include program. Why? Just to reuse, in
Yes.
other programs. If you have same selection screen parameters in different programs, you can keep all of them in a single include program and you can reuse them.
Okay.
But you cannot execute independently. When these selection screen parameters will be displayed, when you added this include program to other executable program,
Executable program.
then
Yes.
only you can display the selection screen inputs whatever you defined in the include program. Okay,
Okay. Yes.
is everyone clear about modularization techniques?
Yes, sir.
So to call the function modules, we use call function and fm name. Call function and function module name we use for function modules. So here function modules can accept the input and return the output. So if someone asks you the difference between function modules and include programs, so function modules can accept the input and return the output, but include programs cannot accept the input and return the output. Okay.
Yes.
Okay. So what is the transaction code to create the function module? SC37. SC37 is the transaction code to create the programs. What is the transaction code to create the global classes? SC24. What is the transaction to create the include programs? SC38. Right? You just need to change the type of the program. That's it. Okay.
Okay.
Shall we create a program using modularization techniques?
Yes, sir.
So in recent project, right? In recent projects, so everyone is using class methods, object oriented class methods. Okay. But there are a lot of standard function modules provided by SAP. So when there is a standard requirement, standard functionality, we can call the standard function modules. You don't need, every time you don't need to create a new function module. So there are a lot of standard function modules, methods provided by SAP, right? If there is no suitable standard function module or class method available, we are going to create our own class method. And sometimes we create new class methods to modularize the code. Now I'll show you how to create a program using subroutines and include programs, and then the next session we'll see function modules. So let me create a program. How to call the subroutine? We use perform and subroutine name. We use the perform and subroutine name to call the subroutine. How to define the subroutine? In between form and end form. Form and end form, we write our source code. But how to call it? By using perform statement, perform and subroutine name. There is one rule you should be followed. This form and end form should be at the end of the program. It should be at the end of the program, because if you write any statements after form and end form, they are not going to be executed. They are not going to be executed. So all your statements should be before form and end form. So that's why we always keep form and end form at the end of the program. Okay. Let me create a program on subroutines. Create. Creating an executable program for subroutines. So just to use subroutines, local object. I'll create some sample program. I'll take two parameters. Or maybe let's create one sample. Right. So let's assume this write statement is my functionality. How many times I implemented it?
Two times.
Two times, right? Two times have written the same functionality. It is duplicate statements, right? These are duplicate statements, right?
I see.
But I need to execute it for two times. So we can use do loop for this. Do two times. Observe this. How can you repeatedly execute the functionality? Anyway, it is not relevant to modularization. I'm just showing it to you. So if you use do number of times and do, what it will happen? It's like a loop. It's like a loop. Whatever the code you placed inside, right? This do and end do, it will repeatedly execute. How many times this statement will execute now? I'll remove this. How many times this write statement will execute? When you keep it in the
Two
do
times.
and end do,
Two times.
two times. Guys, it is not related to modularization, but I'm just telling you. If you write it for do 10 times, it will execute for 10 times,
One time.
right? So to repeat the executions, what we can use? Do loop, do and end do. Okay. If you want to execute any functionality for certain number of times, you can use do and end do. Okay. But for our modularization example, I'll keep the right statement one more time. Now I'm implementing the same functionality two times. I'm implementing the same functionality two times. Now how can I modularize this functionality? Using subroutines. What is the structure of subroutine? Form and end form, right? Form, subroutine name, for example, display, output, end form. This is the subroutine definition. This is the subroutine definition. Now I am going to keep this functionality inside the subroutine. Is it going to work automatically? Is it going to call the subroutine? We defined the subroutine using form and end form. In between form and end form, we are writing our functionality. Is it going to execute this functionality? Is it going to display this output if we execute the program?
No, sir.
We just defined the subroutine. Are we calling it?
No, sir.
To call the subroutine, what we need to use? This one,
Perform.
perform. To call the subroutine, we need to use perform statement. Perform and subroutine name. What is the subroutine name? Display output. We need to write perform display output so that it will execute the subroutine. So what is the statement that is used to execute the subroutine?
Perform.
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 To define the subroutine, form and end form.
And,
Form
and
and end form.
What is the rule to use subroutine? It should be at the end of the program, last statement of the program. Okay? You cannot write any other statements after form and end form here. Even if you write,
okay, yes.
they are not going to work. No syntax errors. For example, let me select single star from KO into table. I'll remove single. What it is saying? Statement is not
Accessible.
accessible.
Single.
Why? Because we implemented that statement after form and end
Yeah.
form. Okay? So after form and end form, no statements are going to be accessible. No statements are going to be executed. So for that reason, we should always keep form and end form at the end of the program. That should be the last statement of the program. Okay? So I'll remove this. If you keep it here, it should work. No syntax errors. Okay? Now, how to call the subroutine? Perform
Perform.
display. What is the name? Output. Right. So it will display the output. If you want to repeatedly display it, one more perform, one more perform, one more perform. Now, how many times this particular functionality will be executed?
3 times.
4 times.
4 times.
Because we are using 4 performs on the same subroutine. But did we write the functionality and again? We implemented only once in the form and end form, and we can call it in any number of times. Can we call it in the different program? Can we call subroutines in a different program using
No,
perform
no,
statements? No.
No, sir.
not
These are
was in the
local to the
program only.
program. You can only use within the same program.
Same program.
So here I simply written one simple write statement, but in general we write some complex functionalities. Server is slow, it seems. Execute. So it executed for 4 times. Okay. This is one way of defining the subroutine. There is another way. There is another way. First, I'll create perform, provide the subroutine name. Did we define the form and end form? Did I define the form and end form? No, right?
No.
There is no form is not exist. Now, how to create the form? Just double click on the subroutine name. It will automatically create form and end form. Why it is slow? So in the standard programs, right, you are going to find hundreds of subroutines and include programs, right? Even though they are procedural concepts and old concepts, you should know these performs and now double click on this, double click on the subroutine, create subroutine, yes. So do you want to create it in the main program or in a separate include program? For now, select the main program, master program. So it created a subroutine, right? So within this subroutine, write your functionality. Clear?
Yes, sir.
Okay. So this is how you can create the subroutine when you double click on it. Okay. So we can also pass inputs and return the outputs for subroutines. We'll see that in the next session. So it will display the output. You can call this subroutine in any number of times within the same program. Let's quickly create one include program. Let me reuse any existing programs. PO data output display. Here we used for all entries. We created another program, right, for PO data output using joins. PO data joins. Observe here, what is the selection screen we are using here? Vendor and
Vendor.
date.
Date.
In this program also we are using vendor and date, right? Now what I'll do, instead of creating the selection screen in different time, multiple times, I'll modularize this using include program. How can you do that? What is the transaction code to create an include program?
SC38.
SC38.
38.
Or you can observe here I am populating some default values, right, to the date using initialization. I'm
Yes, sir.
populating some default values, but here I am not populating default values, right? Let's reuse this functionality, this initialization functionality in here along with validation. Am I validating the input here in the joins program? I'm not validating the inputs, but it is already implemented here, right?
Yes.
In a different program, we'll reuse this validation functionality and this default values functionality in other program instead of writing here. Okay. For that, what we need to do, we need to create an include program. Transaction is SC38 ZDemo PO data validation. Create. Okay, it is taking time to include program for validation. What type of program you need to select? Include
Include.
program.
Include program.
Save it. Now, what is the functionality you need to write? Validation, right? I'll just keep this functionality here. Copy and paste it. Activate it. Your include program is active. Your include program is active now. Now, how can I reuse this program in another program? So, where you need to implement this validation here, right? Now I am in joins. How to call the include program? Include and program name. Now, whatever the validation you are doing, that will be automatically applied to this program as well. Okay. Clear? This is how we can call and create the include programs. Here also we have two ways: creating separately in SC38 and calling here, and we can create the include program from here itself. Now test it. I am not entering anything. It is displaying the same error message, whatever we are using in the other program, right? Yes or no?
Yes, sir.
Similarly, you can call this include program in any number of programs wherever you have similar validation on the vendor number. You don't need to write all these statements. Just call this include program. But what is mandatory? These parameter names, right? Whatever you are using, you need to use same parameters in the selection screen. Same names. Names should be same. Now, let's reuse initialization functionality. Here we are populating some default date, right? This one to this value. So let's reuse this functionality. Now I'll follow other way to create the include program. Include underscore default. I provided some name. Did I create this program? Did I already created this program? No, right?
Yeah.
No, sir.
How to create this? Double click on it. Double click on the program. It will automatically it will give you the navigation to create this include program. So when you see some standard programs, right? Standard programs in SAP, you can see a lot of include programs and subroutines. So all the functionality developed inside this include programs, and they are being reused in different programs whenever we need the similar functionality. So modularizing code is very important. Even if you write a complex program that is working properly, but no one will approve your program if you don't modularize it. Okay. So after creating a program, even it is working perfectly, are they going to approve it?
No.
No. Your lead or someone in your team will do the code review. Are you following proper naming conventions or not? Are you following proper validations or not? Are you following modularization or not? They'll check everything. Even if your program is 100% working. Okay. You need to make sure about the naming conventions and modularization of the program. It is taking too much time. Anyway, when you double click on this, it will display create include program skill and enter your functionality, activate the include program, then automatically this include program will be added to the executable program. Clear? So tomorrow we'll see a few additional options available in subroutines and include programs, and also we'll create the function modules. Okay, in the next session. Function modules, class methods are very important. So please keep in mind that you are not going to write any new ABAP coding in the function modules or class methods. You are going to write regular statements, whatever you have learned so far. Okay? Yes. Create the include program. So that's why if you know the basic ABAP statements, right? You are going to use same statements everywhere. Okay? In function modules, class methods, and everywhere. Only place where you need to implement those coding or statements are different. Anyway, it is taking time. Then just it will create the include program and add the code and activate. Then it should be automatically added to the executable program. So in the next session, we'll see how to create function modules, and then we'll see class methods. How to modularize our code using function modules and class methods. Clear?
Okay, sir.